Events are special occurrences that trigger the software to certain actions. Events can be internally generated by things like timers. For instance, we could set a timer to generate an event every 30 seconds or so. Or by time schedules, generating events like maybe building occupancy at 8 in the morning and no more occupancy at 5 o'clock in the evening. Most PLCs have time schedules and a real-time clock, RTC. They normally have a means to program daily, weekly and yearly schedules, with exceptions. That's holidays to you and me, and maybe during the holidays the lights don't come on. There's no real standard to programming time schedules, except that they're always made as easy as possible, since we normally allow the operators to modify them. External events are triggered by inputs such as fire alarms, emergency stops, or maybe a temperature going high. There are two ways that events can behave: non-interrupting or interrupting. With non-interrupting, the program runs round and round its cycle doing various subroutines, although subroutine 1's not called. If the input comes on, the event enables subroutine 1 to run. I always put my safety subroutines at the top of the program. This makes them easy to find, and it means they will absolutely run even if the program has faults further in. With interrupting events, the event subroutine is completely separate from the normal program execution loop. Not all PLCs allow interrupting events. Here, the interrupters come on. The normal program cycle is completely stopped and the interrupt subroutine is run. It may run through continuously, or it may run through just once and then the main program is re-enabled. One huge problem with interrupts is that they're vulnerable to faults on the input hardware. For instance, Windows 7 used interrupts to read the USBs. If you had your mouse sensitivity too high, it'd be constantly interrupting the main program until it used 100% of the CPU time and your PC locked up. If we want to run through something like a subroutine just once, we need a bit of software called a one-shot. Firstly, to explain this, let's look at some of the terms we use. Here's an event being triggered by an external switch. When the event switches from off to on, we call that the leading edge. When the event goes from on to off, we call that the trailing edge. The event triggers an off, on, off, which is a square wave traveling in time. So it has a leading edge and a trailing edge. If we only want the event to trigger once on a leading edge, we use the software function called a one-shot. It comes on for one execution. It literally, one shot is fired each time the trigger is pulled.